Hello, and welcome to AWS Review, a weekly look at what's happening at AWS and how it might change how you do business. I'm your host, Michael Krause. I am the Chief Technology Officer at Charter Solutions, where we help organizations change and innovate quickly by accelerating their acquisition and use of data.
And I'm your co-host, John Affolter. I'm a lead technical architect on the AWS specialist team at Salesforce, where I work with potential customers and help them envision the possibility that AWS and Salesforce enable together.
All right. Excellent. Welcome back, John. How's it going?
Going well. It's, I know we were talking about this before, but we were talking about how excited we were to get the summer weather. And now I feel like the summer is almost halfway over, huh?
Yep. Coming up, 4th of July is next weekend, and that's going to, for me at least, while it's not really the middle of summer, for some reason it signifies the middle of summer to me.
Yeah, I feel like, a lot of people will be off that week too, I think, 4th of July being on a Monday. So it's kind of one of those, all right, it gives people an excuse to take the whole week off. So, especially in the consulting world, and sales, it kind of seems like it's hard to get anything really done during that time anyways. So it's kind of a wash, I guess.
Yeah. Well, another item on the middle of summer is, I've ridden motorcycle for many years, and I've owned a couple of Harleys, and I own a Harley right now, and I haven't ridden it really for a few years because I've got some back issues that have gotten worse, and the vibration of the bike just makes it, triggers my back. And my wife looked at me and said, "Well, why don't we get a different bike?"
Yeah.
So back in February, we put a deposit down on a Can-Am Spider. It's a 3-wheel bike with 2 in the front, 1 in the back.
Yep.
Beautiful bike. I've ridden. I've done probably 45 minutes to an hour of riding on them so far, and it doesn't trigger my back. It works. We love it. But ours was due in April.
Oh, of course.
And we have not seen hide nor hair of it yet. I was talking to the dealer last week, and they said, "Oh, we finally got a date from the manufacturer, or at least a week. It's expected to arrive the last week of July." So we're hoping to be able to ride throughout the summer. And now we're at the middle of summer. It's not here yet. We're hoping it might be here by the end of July.
Oh man, the brutal supply chain issues. That's
exactly.
It's really too bad. But yeah, I like those 3-wheelers too. It's definitely a different riding experience. And my family, I grew up riding dirt bikes and bikes all the time, and I definitely can understand how different it is. It kind of reminds me too of the snowmobiles when you went from sitting backwards to the ones that sit forwards. It's definitely a different riding experience for sure.
Absolutely.
So. But yeah, I was gonna do my weekly Goodwill haul. I got another one here. Superheroes have issues as well. So
I love it.
Batman needs anger management, and you have the hothead here, Superman dual personality. So
I saw a great cartoon once, and Superman and Wonder Woman are chatting, and she starts spouting all these things, the unsaid truths about the different superheroes, and then she looks down, her golden lasso was wrapped around her leg.
Jeez. I mean, yeah, that's I think it's kind of a funny. I love this shirt. Just it kind of brings things home. It's like, superheroes have issues too, so don't you worry about it. But
exactly.
But before we jump in here to the topic of the day, which is an exciting one, I really like ingesting data from non-AWS systems. Let's take a look at what's been happening over the week at AWS.
Excellent. So, unlike last week where we had nothing to talk about on this, we've got a couple. So the first thing to share is AWS IoT Express Link is now generally available. And for people who are unaware of what it is, It is software for partner manufactured connectivity modules to make it easy for the partners to connect their modules to AWS. So historically, they would have to write a lot of code, tens of thousands of lines of code to connect, secure, transfer data, all of that stuff. So whether it's industrial sensors, home appliances, irrigation systems, all the different types of IoT systems, consumer and business related. This simplifies and reduces the cost of connecting those to AWS IoT. John?
Yeah, I think that's a big one, especially because a lot of these companies kind of have their own custom IoT platforms that they've been working on already, and this definitely accelerates the ability to leverage IoT within AWS as well.
Absolutely.
AWS also came out with, or SageMaker Ground Truth now supports synthetic data generation. So you can now generate, large sets of synthetic image data, and, combining your real world data with synthetic data really helps kind of create a more complete training data set. And I think this is a really big one too, just on the terms of SageMaker and integrating external data sources as well. As if you can integrate SageMaker Ground Truth with some of the things that you're doing in the real world and have that integrated with some other systems, aka like Salesforce, you can label that data and correct your model and optimize it in real time. And for it to be able to generate synthetic data, then you have really a much larger data set that you can have a much more accurate and optimized model for. So definitely a really cool update here.
That's awesome. That's awesome. Kind of on a related front from an ML perspective, Amazon has recently released in preview so far, Amazon Code Whisperer. So if people who are familiar with GitHub's Copilot software, what Code Whisperer does is it helps developers write better code by reducing routine and repetitive work. It's trained on billions of lines of code powered by Amazon machine learning. And it examines your code and your comments, and it presents you with syntactically correct recommendations. So not just improved autocomplete, but actually generation of complete code snippets, functions, things like that, just through looking at comments and existing code. So that'll be interesting to play with. I know some people who've played with GitHub's Copilot, and it's interesting. Doesn't always do things right, but it's an interesting step. So it'll be cool to play with Code Whisperer to find out if they've taken it to the next level.
Yeah, I think it's always good to just have the recommendations too, and as you change those recommendations, you're just improving the model over time as well. So it's kind of a similar type experience, I guess, as far as just that auto correcting ML, similar to how QuickSight Q does it as well, how you can do it really in line and say whether that suggestion is correct or not.
Yeah. And right now, whenever I code, I use a product called Tab 9, and what it does is it's ML based, but it's just richer autocomplete. It's not here's the next thing, but here's a completion of this entire line. But taking it to the next level where I can say things like, find the largest prime number for, between 0 and X, and have it actually generate the entire function for you is intriguing.
Oh yeah, no, definitely a big time saver, especially, if you're working between different libraries, possibly different languages, and trying to remember all that syntax can be.
I always used to joke that the ultimate, tool would be the PowerPoint compiler. So all you have to do is create a deck, and then you run it through, and it creates the software for you.
Yeah,
this is a step in that direction.
I mean, hey, I would, within the next 10 years, who knows? I definitely see that as a possibility.
You'll never know. At some point, it'll come in, and you'll say, I want to write software to do this. And it'll say, no, you want software that does this, and here's the code.
Yeah, then we're gonna work ourselves out of a job here, maybe, but yeah, not for a few more years. That's why
Exactly.
you got to stay an architect. You just piece all.
Play with all the stuff, but don't get involved in it anymore.
Yeah, yeah.
All right. So let's move on to the topic of the day, which is going to be a fairly large topic. We got a lot of items to cover. And that topic is ingesting data from non-AWS systems. Or in other words, a lot of things we've been talking about is how do you do things inside AWS? You have data in S3. How do you move it to a database? How do you do processing on it? How do you curate it? So today we're going to look at how do we get data into AWS in the first place, right? John, what do you think?
Yeah, I mean, this is kind of an interesting one. Well, I guess I'd like to start off with the question, but what about the differences between, okay, we're getting AWS here, all this data into AWS in the first place versus maybe continuously updating it versus maybe continuous bidirectional stream,
Right.
I guess maybe let's start off
So,
and maybe break down some of those categories and
yeah.
how that might be.
Excellent. So a little categorization. So when I, at least when I think about migrating data into AWS, I think of a few things. One is the obvious ongoing data movement, right? I have data changes on when that data changes, I move it into AWS in either a real time, maybe streaming kind of mode, or in a batch mode. It's like think about the traditional nightly batch where I take all the transactions of the day and I have a piece of code or some software that will move that data for me. But there's a few other interesting ones. One is migration, right? So if you're talking about, I have an application or maybe a data warehouse and I have a bunch of data, I've got 100 terabytes, I have a petabyte, I have, something along those lines. Uploading that over the internet is not necessarily a good idea. So there are needs there to migrate historical data sets to AWS so that you can start working with them and continue to enhance them over time. Um, Another interesting kind of, I'll say it's a subcategory that falls into this kind of data migration or batch thing is collecting data from non-connected sources. So imagine you have you're building a power plant in, an Eastern Bloc country, and you've got no internet connectivity
Mhm.
there, but you do need to connect up to your machinery and your devices and collect data, kind of IoT-ish kind of data, uh, and you need to get that back to AWS as well. Right, so that's another kind of specialized category of data movement, data migration that kind of falls into that batch world.
Mhm. Yeah, I think I when you're starting off and just getting into data and you're just getting it into AWS, that's one thing. But just like to your point, there might be a consistent updating of data that you can't connect to the internet at any time. And there might be a situation where economically maybe that it doesn't make sense to do that either. And you might actually save money by just, shipping a snow cone out every once in a while. So I guess maybe I know that you've seen a couple of those situations where it's like, all right, wouldn't it just be cheaper to just one time a month just send a snow cone out? And it might not even be because you can't connect to the internet. It might be just purely economical as
Right.
well.
Right. So, so you bring up snow cone, and for our listening audience today, let's just kind of talk a little bit about the snow family and then kind of address that question. So, the snow family with AWS, for people who are unfamiliar with it, is an appliance-based solution for moving data from non-AWS locations to AWS. So the classic use case is I have a database I need to move to AWS. It has a petabyte of data, or it's got, you know, 50 terabytes of data in it. And I don't want to move it by copying the data over the internet. you can actually go log into AWS and request one of the Snow family of devices, and they ship you the device. It is in a hardened container. It's locked. It's secured and encrypted. Once you get it, you have to go online, get a release key that you enter in that will unlock it so that you can load data into it, and then you ship it back. And Amazon will take that data off the device and load it onto S3 within the data center for you. So there's kind of three basic levels of this. One is the like you mentioned, Snow Cone, which can handle up to about 8 terabytes. Pardon me, I'm just going to double checking my notes on that one. Yeah, Snow Cone can handle up to 8 terabytes of data. Amazon Snowball is a larger device and can handle up to 80 terabytes of data. And then this one I'm guessing isn't used as often, but it's a really fun one, which is Snowmobile. And Snowmobile can handle up to 100 petabytes. So where Snow Cone is, think of it around the size of an external hard drive. Snowball is around the size of like a, desktop computer. Snow Cone is Snowmobile is a semi truck that they send out with a physical guard and all this stuff. And it's got fiber optic connectivity. So you can actually pull the truck up to your data center, load all the data on the truck. Then they'll drive it back to their data center and load all that data onto S3 for you.
Yeah, I just love the fact that I feel like I just want to be able to order one of those someday just to see all the guarded truck come up, and like that's just got to be a really cool experience to go through that.
I happened to be at the reInvent conference when they introduced Snowmobile, so I got to watch them drive it onto the stage.
Oh, geez.
And then they had it parked in the expo, so you could go and take a look at it. It was a smaller version of it, not a full semi, but think more a U-Haul. But kind of back to your question is, could I use those to move data on a regular basis? Mm-hmm. And the answer is yes, but there's a couple of caveats. One is that because it's physically moving the data, you've got time constraints around shipment cost, or around shipment time. So I have to order it. It comes in. I have to then load the data onto it. So there's another manual process there of I have to export and get that data onto it. And then I have to ship it back and have them upload it onto S3. And then I can start processing, right? So if you think about, a couple of days shipping one way, a day or so for you to get the data loaded on it, and then a couple of days shipping back, that's not really conducive to fast analytics, right? So it's not only batch, it's really slow. It's like weekly batch. And the price, is not unreasonable. A Snowball costs around like $60 plus shipping and handling. Snowball costs around $300 to $400 plus shipping and handling. So depending on the data you're dealing with, $300 to $400 a week may not be that big a deal. But where these things can shine in that particular scenario is in remote work. So let's take, some, lesser developed country doesn't have, good bandwidth, good internet connectivity, or you're out in the middle of nowhere and you're building something and you need to, be able to connect up to devices, gather information, do IoT type stuff. You can take these Snowballs and send them in. Some of them have the capability of running Lambda and machine learning models and things like that right on it. And you can use it as kind of a local processing and data collection engine. So you can bring it in, you can plug it in, collect data, and then you can do swaps. Order another one, bring it in, swap it over, send the last one back, and upload the data to the cloud. So that's a use case where you can do that. But I would say for general data center type stuff, really you're using those things for an initial migration of a large data set. And then you're looking at using some of the other technologies that we're going to be looking at for the ongoing update of that data.
So, yeah, I mean, that's a good segue. So, obviously that big initial lift, you might use something like one of the things from the Snow family, but, what about as you move to continuously updating and then I think about something like database migration service that maybe it's, mentally you're thinking, oh, that's just to get things going, but really it's kind of a continuous update as well.
Yeah. So let's kind of talk about it. There's the way I think about it is there are file transfer based solutions out there. There are data streaming based solutions. There are integrated solutions, so pre-built integrations to like SaaS software and things like that. And then there's kind of a set of things that kind of fall across these things, like data migration service. So data migration service is kind of somewhere between a batch based database point to point integration and a streaming one. It kind of depends on how you've got it configured. So for people who are unfamiliar with DMS, data migration service, what it does is allows you to replicate a database in one location to a database on AWS, or a database in another location, actually. And it'll do some things like, mapping. So if you're going from SQL Server to Postgres or something like that, it has some capabilities of doing mapping. And a lot of people will use it for initial data loads to get things out there, and then sometimes use other technologies. But it has the ability to go out and, in a batch way, look for updates, or if they're small tables, you can do complete changes, or you can do it in more real time and do change data capture. And now there's a limited set of databases you can do that with, but the capability is there if your database supports it, where it'll watch the transaction logs and watch for changes and migrate those changes into the other database. This is a good way of synchronizing databases across. It's very good for initial data transfers, grabbing data out of application databases and bringing them across. And I believe it can write to S3 as well as a number of RDS and, I think, Redshift instances. So that's kind of a specialized data movement tool. But I think, maybe what we should do from there is start talking about what people generally are most familiar with, which is file transfer.
Like good old SFTP and FTP and just the old school stuff, and then storage gateways. And I guess, everyone talks about streaming data and doing all these fancy things. Usually, most of the time that I hear about it, people just are using one of the AWS transfer families. It's kind of usually what I hear about. But I don't know if you have your thoughts on that.
It's the new world is kind of going towards streaming because, as we've talked about in the past, there is a increased demand, increased hunger for fresh data.
Yep.
Right. And in the past, fresh data was, if I could have yesterday's data today, that would be awesome. Right. And now if I could have the last transaction any customer made.
Yep.
Yeah. That would be awesome. Even if it was a second ago. Right.
Yeah.
But file transfer, in my mind, is still kind of, the bulk of what is happening today. It's not where things are going, in my opinion, but it is still the bulk of what's happening today. And, you mentioned, FTP, SFTP, pretty much every company has some mechanism of moving files either to their systems or from their systems using an FTP based protocol. So file transfer protocol, we're going to grab this file, we're going to upload it, download it, whatever it might be. Amazon provides the AWS transfer family to do that. And the AWS transfer family basically provides an FTP, SFTP, or FTPS endpoint that can be logged into by your customers or by your own company on premise, and allows you to upload files to either S3 or Elastic File System, EFS. So that's kind of the classic. I already have the ability to move these files. I have systems and processes that do that via FTP. I just want to do that to AWS. Amazon Transfer Family provides that capability. Once it hits S3, now all the things we've talked about before with regard to curation and transforming and all that stuff can pick up and process.
Yeah. And that data sync now, it allows you to do that in other clouds and keep everything updated and consistent across the other as well.
Yeah. So the FTP concept is a point in time initiation, right? I have to push a button. Now I may automate that pushing of a button, but there is somebody has to connect up to that server, copy the file, disconnect from the server, right? You can script all that. It's really slick. It really works. But you do have to write some code on your side. There has to be some system on your side that supports FTP that does that. Data sync is interesting because data sync, in its simplest form, is designed to monitor a file system and keep it in sync with a file system of some sort on AWS, whether it's S3 or EFS or FX for Lustre, or FX Lustre or FX for Windows, FSX for Windows. Get all those letters properly together.
So many acronyms. We're in the acronym world.
Yeah, but it is another way, because if, for example, if you've got a file server on premise, you can install the data sync agent on that file server and authorize it to monitor one or more directories on the hard drive. And as files are put on those directories or changed on those directories, it will sync that to a replica on AWS. So this is another way of if you just want to transfer files to S3 for processing, you just drop them in that directory and let data sync move them for you.
Yeah, and then you don't have to worry about scripting every little thing and continuously having to update that. And
Yep.
that can be a big headache, especially if you're working in this multi cloud world that a lot of people are working in as well.
Yeah, and data sync is a newer technology. The other one to be aware of that's been around a little longer than data sync is storage gateway.
Mm-hmm.
Now, storage gateway, and we're specifically talking about storage gateway for files. What storage gateway does is it's an appliance or a virtual machine that you run locally in your data center, and it basically provides a file server. So it's a local file server in your data center. But what it does is it has local hard drive that it uses as a cache mechanism. But whenever you put files on that hard drive, it takes those files and pushes them up to S3 and stores them on S3. So, for example, if you had 500 gigabytes of file space on the local machine, you could put 10 terabytes of data on it. But what it does is, as you write those files out to the machine, it writes them up to S3, but it only keeps the most recently used data in that 500 gigabyte local space. So you could have 10 terabytes up of data, and if you go and say, I need this file, if it's not there, it'll download it off S3, but it'll make room by getting rid of other stuff if it needs to. So I've seen that used in the past as, not just to support local file systems that are backed by S3, but also to do data transfer for data analytics, things like that. But I'm seeing people lean towards data sync a little bit more these days.
Yep. No, it makes sense. And really more that, everything in AWS is moving towards that managed feel where, kind of it lets its tentacles go through other systems and all that, and links that all back together. Yep. I guess let's talk about some of the newer, I wouldn't say newer, but I guess the more interesting ways of getting data into AWS within the streaming family, and maybe
Sure.
maybe how using different streaming technologies might be different for different types of use cases.
Absolutely. And Amazon has a few numbers. It's kind of the hard part sometimes is wading through and figuring which are the right ones for your use case.
Mm-hmm.
So the first thing they have that's been around for a while is the Kinesis family. And the Kinesis family is a time series streaming data solution. And the one that was the original and that people probably know about the most is Kinesis Data Streams. And the idea of Kinesis Data Streams is you write records to Kinesis Data Streams, and it takes and delivers them to whatever system is on the other side who needs to consume them. And it maintains order, and it scales massively. So you can do lots and lots and lots of records. They limited to, I think it's a 1 megabyte writes. So if you have a record that's bigger than that, you're going to have to find a way to split it.
Mm-hmm.
But it allows you to very quickly collect data from a number of different sources and process it on the other end as a time series stream. So order matters. It does require that, typically you either have some code or pre-built integrations that work with Kinesis on the source side. I've seen companies who want to treat everything as streaming, and they will, they might have a ERP system and they dump an export every 5 minutes, and then they have a piece of local code that reads the export file and writes all the individual records to Kinesis as individual pieces of data. And now it's streaming, and now entire streaming pipelines can work upon that.
Yeah, and that's something that I've seen some questions get asked too about. All right, what if it's coming in a batch, but then we want to go from batch to streaming? So just like you said, you're just going to have to write a little code to break that all up into individual records and do it from there.
Right. And there's a couple of places where you can do it. I've seen organizations do it on premise. But the other thing I've seen is that conversion happening in AWS. So they'll use a file transfer method to upload a file to S3, which could include any of the things we talked about, or using the Amazon command line interface to run and write an S3 put to load the file, and then use Lambda evented off that file arrival to take that file and split it up into records and emit them into Kinesis data streams.
Yeah, I saw one around getting data into Dynamo in the batch form, just because you can only write 25 items at a time, but you can do as many calls of those 25 as possible, but just, maybe going into either S3 or processing it with EMR, or, a lot of different ways to kind of look at that. And, to your point too, data streams was kind of the first one, but, you also have, Kinesis Firehose if you maybe have a near real-time use case. So that's also something really interesting too, is where's that break off between real-time needs and then near real-time, and what does that experience need to be like? And really, because you always have to ask people, all right, do you really need it real time, or does it just have to feel real time?
So the term real time is extremely loaded as a term, right? My dad used to work in the paper industry, and he worked in process automation and electrical. And in his world, real time meant about managing the speed of motors, right? So real time was measured, not in milliseconds, but in microseconds, right? They're getting data in microseconds. They're making decisions and making changes in microseconds. To us, when we talk about things, real time is often in the scale of milliseconds to a few seconds, right? That is, I want to see all of the latest customer orders, right? Well, if the last one that you see is 3 seconds ago, but another one just came in, you don't see it quite yet, it's not a big deal, because it'll show up within a second or two.
Yeah.
Right. So real time and near real time are very interesting terms. And kind of the way I look at it is, if you think of a sliding scale, and on one end of the scale is batch and the other end is real time, you go from, monthly to weekly to daily to hourly to every 30 minutes to every 10 minutes. And when you start going to kind of like from every 10 minutes down, 5, 4, 3 at every minute to starting into seconds and things like that, that's where you see a technology shift happening.
Oh yeah.
Up until that point, you can do file transfers every 10 minutes, right? You could actually do them, if not too big, every 5 minutes, right? But there's an inflection point where it's better to start switching over to streaming tools when you get down into that level. So things like Kinesis data streams is very fast, right? If I have a producer that's writing to the stream and a consumer who's constantly reading, the latency is not large, right? But Kinesis Firehose, and just for clarity for people who might not be familiar with, the use case for Kinesis Firehose is really more about taking streaming data and writing it into a destination. rather than acting as providing a time series buffer between a producer and a consumer. Right? I could write a consumer that reads Kinesis data streams and writes a file to S3. I can also use Kinesis Firehose, which you can either write directly to, or you can subscribe it as a consumer of a Kinesis data stream and have it write to Amazon S3 for you. So it's really a publisher to specific destinations. And I think the primary destinations for Firehose are Amazon S3, Amazon Redshift, and Elasticsearch. There might be some others, but I think those are at least the big three. But, so if you've got data streaming in on Kinesis data streams, you could have a consumer that is consuming that and doing some real-time analysis on it. You can also attach Firehose to it and have Firehose write it to S3 or write it to Redshift, so you can do longer-term analysis across, weeks or months worth of data.
Yeah. And you're saving, just switching to Firehose, you're increasing your throughput ability and really cutting down on costs quite a bit too. And I think that's kind of the big thing.
It simplifies things, because even when you're streaming, oftentimes you want to capture that data for longer term analysis, right? In the past, we've talked about Kinesis Analytics, which allows you to look at a Kinesis stream and actually run SQL against it and do analytics directly on the data that's in the Kinesis stream. But if you want to go longer than, the 24 hours to 7 days that Kinesis data streams will hold that data, you need to have that data in some sort of data lake or database where you can run your queries against it there. And that's where Firehose is very powerful. And they work together. But Firehose has more latency, because with Firehose, what you do is you give it a couple of parameters and say, when you receive so many records, or you receive so much data, or so much time has passed, then write that data out as a batch. And I think the minimum time window is like 60 seconds.
Yeah. It's
right? 60 so you've got a potential max delay of a minute before it shows up in your final destination. And if that's real time enough for your company's needs, which again, for probably 99.5% of companies, that's good enough.
Yeah.
Then you're fine, right?
How about when you start getting towards some of those edge cases that have to be in the millisecond, microsecond area? What are you going to be possibly leaning on? Obviously, data streams plus lambdas, or maybe move into the danger zone of Kafka even.
Well, actually, to be honest, when you get down into those types of things, the network latency alone is going to kill you, right? Yep. So as long as you can handle, 3-digit milliseconds to seconds, you're probably fine using Kinesis or Kafka or things like that. If you really need to push down below that, now you're looking at doing things like either Lambda at edge to put processing closer to the edge in one of AWS's edge locations, or leveraging something like Amazon IoT Greengrass to push your ML models and your Lambdas and your code directly to a physical on-premise location and allow you to do local processing of data while still shipping it back as well. So that's the other thing that we haven't talked about is not only are we talking about capabilities to bring data in, and this is probably make a note another show, there is the capability to push processing out closer to the edge or closer to the origin of the data. But Kafka is another streaming tool that's got a lot of really great features. It kind of competes with Kinesis in a number of ways, but there's a very large and vibrant community of Kafka users. So Amazon provides Amazon managed streams for Kafka as well. So what they're trying to do there is provide you all the capabilities of Kafka, but reduce the amount of management and maintenance work you have to do to maintain that particular set of servers, that cluster. And recently they released serverless Kafka as well.
I think that's definitely It's an interesting play by AWS, and it just speaks to them being customer centric. And depending on if you're already using a Kafka cluster or you have the talent already,
Yep.
might as well leverage it. But you bring up a good point with IoT, and just even the latest update with IoT Express Link now generally available. I mean, there's got to be this huge push towards getting all of this data from all of these different sensors and home appliances and putting it all together. And I think about what AWS's role is in that, and I was putting together some architectures with some teammates the other day of looking at just what are main parts of an IoT distribution. And I really think about the managing of the devices. There's a lot of different ways you can think about managing devices. You can think of it like from just the device registry to also stuff like IoT site-wise, where you're looking at kind of a 3D or distribution of your network. But how about all of that data and how that's coming in and to your point, out of AWS as well? What do you see kind of the future of that and the manageability, I guess, and not the topic, but getting the data in and out of AWS?
Yeah. So, we kind of mentioned pushing processing out, and IoT is a way of doing that. So IoT is not just data collection. IoT is remote management of devices and bidirectional data flow, configuration flow, things like that. And let's save the conversation of logic and all of that stuff for another one. I think we'll have a session on IoT specifically, and maybe a session on pushing logic to the edge. But from a data collection perspective, IoT devices generate a lot of data, but sometimes that observation of that data and the processing of that data is myopic when you're doing it locally, because you only see certain data, right? So if you are a college campus, right, you might have a building that has HVAC system on it, and you might collect data from it, but you might do that across all the buildings, right? But every building has its own building controller. And depending on where you're doing your data collection from IoT, it could be on an individual sensor, sending data all the way back to AWS. It could be at the building controller, in a number of places, but it won't see the entire campus. It might not see the entire building. It might see only part of the building, right? If the building's split in some way, part of the building may be under one system, part of it under another.
Yep.
So having the ability to bring that data back is important, and having the ability to collect the data across all of it. So if one of your solutions is providing energy management, it may be better to look across the aggregate of the buildings to determine energy management capabilities and best strategies, rather than looking at a single. IoT provides a number of mechanisms to collecting that data, having it come back, passing it through MQTT, and then it can be routed from there to any number of different AWS storage destinations for further storage and query and analytic processing.
Yeah, I think it's all about linking it all together, and it's just when that's just got to be a really tough thing to do when you don't have those frameworks in place already.
Yeah,
I know I had to experience it as well.
And I've done work with AWS IoT back when they first released it, and they have released so much stuff since then to automate, make things easier. In some places, it makes it more complicated because now you need to know more things and know all the pieces to pull together. But one other thing I wanted to kind of mention on the streaming side, which people don't think about as much, and we talked a little bit about in a prior session, is Amazon Event Bridge. Right. So Amazon Event Bridge allows people to publish events, and they can be published from inside AWS, and they can be published from outside AWS. And Event Bridge, it's not time series like Kinesis is, but it does allow multiple systems internally to subscribe to those events and process them. And those events can carry data. Now, You're limited to, I think it's like 256K for each record. But if you're dealing with a lot of small records, EventBridge is another option that you have to look at that.
Hold on one second, Michael. Somebody was at my door. I gotta.
This is the joy of doing doing live stuff from your home. You never know what's going to happen. So while John's away, I'm going to talk about one other area that's kind of obvious but should be mentioned anyway. Is you can always create custom code. You can always build your own system. So, for example, if AWS doesn't provide all the things that you need in one of their existing pieces, you can write a piece of code, deploy it as a Lambda or an ECS container that presents a REST API, make that API available to API Gateway, and then your on-premise systems can call that API to deliver data as well, and your custom code can produce that data to whatever destination it needs to.
Yeah, no, and that's a good point, Michael. Yeah, I'm back here.
No problem.
No problem. Yeah, that's a good point. And also too is, as we kind of look at getting data into AWS and doing it in an API driven way. So obviously the shameless Salesforce plug, we have MuleSoft, but also there's Amazon AppFlow, there's EventBridge plus the event bus on the Salesforce side. So, I guess just kind of from a holistic viewpoint is, where are some of the best places to manage all of these integrations? So you're avoiding doing the whole API point-to-point solution.
Right.
You're avoiding, where do you see kind of the future? I really like the two connected event buses. I also like AppFlow and some of these managed connections as well, but there's going to be so many different options here coming through. I guess, what do you see as some of the bigger, the bigger more about manageability as opposed to like pure optimization, I guess.
Right. So from a manageability, so when I think about manageability, I think about it from a couple of different directions. The first one is things we've mentioned before, which is reducing the heavy lifting, right? So let's take the Kafka thing, right? Before MSK, if you wanted to run Kafka, you had to set up your own EC2 instances. You had to install Kafka on it. You had to manage all of that stuff yourself. Then they came out with managed streams for Kafka, MSK, and now you just tell it how many servers you want and things like that. And Amazon takes care of that. And now they come out with serverless Kafka. And now you just say, I need this much capacity. Right. So that's one side of the management, is getting rid of the specialized knowledge that is not really value add to your organization. The other side of management gets to endpoint integration in my mind, right? So it's really great to be able to have Kafka and Firehose and all these things, but you still have to do something on the other side, on the source side, to talk to it, right? And as more and more organizations move to SaaS software, and you see more and more on-premise COTS software, off-the-shelf software, interact and partner with AWS, you're going to see more and more pre-built connectivity, right? So this is a growth area for AWS in my mind, and it ties back to some of the things you and I've talked about in the past, where AWS needs to become a little more opinionated about certain things. Integrations with source systems are one of those. So in the past, there are companies like Zapier and Stitch Data and all of these guys, Fivetran, who were third parties to help you with pre-built integrations to other systems and getting that data into AWS. AWS has released AppFlow, which is another tool that does that. And I think they've got a little ways to go. It'll be interesting to see how they develop integrations with AppFlow and how they develop a marketplace of integrations, because I'm going to assume that they will have partners providing AppFlow connectors, if you will, two different things that are available in a marketplace type scenario. So for people who are not familiar with AppFlow allows kind of point-to-point integration from a SaaS software platform into AWS. And AppFlow is primarily what I'll call a scheduled solution. So you tell it, hey, go and get the latest data twice a day, once a day, whatever. And it'll go get that data and bring it over. And it's bidirectional. So you can actually use AppFlow to send data back to it. So it's a bidirectional pipeline. But with AppFlow, you don't have to go and write code on both sides. You just configure it. So now you're moving to a pure configuration thing where now you say, hey, connect up to Salesforce, connect up to Zendesk, connect up to Jira, whatever it might be, and bring that data over to me. Now, what's really cool, we talked about EventBridge and its ability to move information back and forth. If a company, say like Salesforce, who supports both AppFlow and EventBridge, wanted to use AppFlow to deliver data in real time, there is an integration between AppFlow and EventBridge where you can literally trigger AppFlow to move data based on EventBridge events. So if this third-party SaaS system emits events that represent changes in the data set on EventBridge, that can be used to immediately cause AppFlow to move that data in, which allows you to provide kind of event-driven data streaming that deals with data larger than the 256K limit of EventBridge.
Yeah, it's a really interesting way to look at it too. And there's also ways that you can get around the Salesforce API limits as well with that. It's going to be really interesting to see how things are broken up and which events inside Salesforce are handled by just the eventing inside Salesforce. So you're not moving stuff across the network at all versus, all right, what can we do once and have like maybe just this big object come over from Salesforce and kick off all these, a bunch of different workflows on the AWS side. But how do we minimize that back and forth and have a bunch of other workflows get kicked off from there? So that'll be an interesting evolution, I think. And just to your point is what is handled by AppFlow versus what is handled by maybe EventBridge on the AWS side or Event Relay on the Salesforce side. So I don't know. That'll be an interesting evolution. Also, too, what about the direct connections that they're creating as well, like between Salesforce and DynamoDB and some of those other ones? But yeah, I don't know. I think everything will eventually keep moving towards S3 in some way, either S3 or EventBridge. And I don't know. I think there's a lot of good updates that are coming within Salesforce to S3 and just S3 in general. But I don't know. What do you think is like the ingestion point? Obviously, S3 is kind of a big clear winner in my mind, but what do you think that'll evolve over time and just go towards the purpose-built stuff that AWS always tries to do? Or I don't know.
I think it's going to be a mix, right? So let's walk into the future a little bit, and everybody's competing more and more in real time, right? The people. Probably your best example of competing in real time are Google ads and DoubleClick and people like that who are constantly monitoring what you're doing and trying to find the best ads to get you to take action and buy something, right? So the more and more competition moves towards real time and people need more real time data, you're going to see more and more data coming in real time via streaming. And that streaming may be through any of the tools like Kinesis and things like that, or it may be more near real time based on events that represent data changes, either combined with AppFlow or not combined with AppFlow. But once that data gets into AWS, whatever way it goes, there are two paths it may have to go down. The first path is storage for future use, right? The second path is immediate processing, right? So if I need to take and I have this data streaming in, and the first thing I need to do is run it through an ML model and generate a recommendation and then send that back to a customer. That's a processing path, a streaming processing path it has to go to. But I most likely want that data, combined potentially with the recommendation, combined potentially with whether or not the tech customer did take action on that, to use for future training of that ML model.
Mm-hmm.
So S3 is definitely kind of the go-to right now for long-term storage of this information for inexpensive stuff. Things like Aurora and Redshift are the go-tos for data that you operationalize and use regularly, whether it's transactionally or analytically. But if I've got, a petabyte of data of which I only use a terabyte of data on a daily basis, and the rest of it is really I'm keeping for future things, I shouldn't keep that in Redshift. I'm paying to store data that I never use, right? So I think S3 is always going to be there as a destination, whether it's for long-term storage, archival, data lake kind of things. But the other systems, the purpose-built systems, will basically be based on the different individuals' needs or companies' needs. So if you're using DynamoDB for an app and you've got a stream of data coming in from some partners that impact how your app behaves, you're going to want that in DynamoDB. If there is a direct built via AppFlow or some other tool mechanism for delivering that data to DynamoDB without you having to do anything, that would be awesome. In the near term, you're going to write some code and deploy it via ECS or Lambda to consume that data and update DynamoDB. But these are the kind of the gaps that Amazon's going to be constantly evaluating and determining based on customer feedback where they need to fill them in.
Yeah, I think, it's also an interesting dynamic when you start to think of data as a product as well, and thinking about maybe ISVs or different like multi-tenant situations where, I guess how does that maybe change the way that you're thinking about ingesting data into AWS or even another aspect too, not to ask too many questions at once. But,
when we only have a couple minutes left.
But what about just being able to track the data, the data lineage as well? And, how we have all these data sources. In your mind, get it into AWS first and then worry about it? Or what do you think?
So in my mind, where I see the industry going is around singular pipelining of data.
Mm-hmm.
So, and I think we've talked about this a little bit before, which is in the past, and the past may include today for a number of companies. If you had a transactional application that needed data from Salesforce, for example, it would integrate directly with Salesforce to get that.
Yep.
If I had an analytics need that needed data from Salesforce, that silo would talk to Salesforce to get that, right? So I've got multiple point-to-point integrations with their own lineages and not a lot of coordination as to what's real for a particular need. So where I see things going is organizations, like you talked about, data is now a product and I'm going to manage it. So if I need data from Salesforce, let's say opportunity information, and I have an app that needs it, I have analytics that needs that, and I have a piece of ML that I want to run it through and send the results to the sales team, there should be one integration, and that's where it's going to go. There'll be one integration to Salesforce that brings that in, and we will have history and lineage from that. Now, at some point, we may pull that in, push the raw data to S3. We may take and do some curations of that. There may be some divergence because I have one curation for purpose for one thing and another for purpose curation for another thing. But now we'll know where that divergence happens, and we'll know what happened to create that curation. Right. So now what ends up happening, as soon as it becomes inside your organization, it is a singular asset that you can then build other data products off of for different purposes.
Yep. And then publish that data set as a curated, governed data set.
A governed data set, and you publish it. You can publish it internally, or in an upcoming episode, we'll talk about the ability to publish those things externally as well.
Yeah, that's a fun one too. I love the product conversation. So yeah, it's a good way to end it here.
Yep. Yeah. Amazon's, there's still a massive amount of opportunity. And there is pressure is the wrong word. There's opportunity for companies to change how they're doing things here. And I believe that kind of data ingestion will converge and become its own capability within organizations to provide those data products as a service broadly within an organization and an ecosystem around that organization.
Yep, absolutely.
Excellent. It's 12:30, and I'd like to say thank you to everybody for joining us today. It's been a fun topic, and we hope you've learned something new. Please follow us on LinkedIn, subscribe to our YouTube channels, and we will have another session coming up soon. A little bit of housekeeping. Probably should have put this at the beginning of it, not at the end. Next Monday is a holiday. We will not be having a live cast next Monday, but we will be back again on the Monday after. So we'll see you all in 2 weeks. Thank you very much.
Happy 4th, y'all.